So also, just kind of curious why you guys came to this presentation. There's like 5 others going on right now. So if I could get you guys to raise your hand, I'm just wondering what you're sort of expecting to get out of this. Are any of you guys security professionals? Nobody at all. Development people? Anybody? Developers? Okay, lots. Students? Any students? IoT people? Anybody interested in IoT? So mostly developers. Okay, how many of you guys have seen mTLS before, have worked with mTLS? Nobody at all. Okay, that's good. So let's start with what it is. If you guys, this is going to be a problem. If you guys know what HTTPS is, or just regular TLS, basically you have a certificate and a key, you put it on your server, and then the client that connects to the server knows who the server is and can sort of trust them. They can tell if they actually want to connect to that server or not. mTLS is basically just you put a certificate and key on the client as well, so the server can tell who the client is. You can see a little bit how this works under the hood over here. So I think like the first 3 steps are regular TLS, and then past that it's mTLS. So the first step is the server sends its certificate to the client. The client decides if they like it or not. If the client decides it's okay, they continue the transaction, and then the server asks for the client certificate and checks all the details, sees if it trusts the client, and then they negotiate their cryptographic info, the algorithms that they're going to use to communicate, all that sort of thing. mTLS is sort of a niche solution. Of course, it's not going to defend you from everything. It's only on the transport layer. Coarse-grained access as a result. So once you connect with a certificate, you're going to have basically access to whatever is behind the transport layer, so whatever application. And it can be secure with a couple of additional operations at the same time. So you don't just want to have TLS, since it's only on the transport layer, but you also want to have like some sort of username password login, maybe OAuth or something like this, and a WAF server in front, a web application firewall, to additionally defend your requests and check what's inside of them. And the other big problem with mTLS, or why it wouldn't be used more frequently, is that certificates are difficult to do properly. They're very finicky. There's a lot of small settings that you have to get right. And it tends to sort of assume that you meant to do whatever you did. So if you do it wrong and you're not actually defending yourself, it doesn't tell you. It fails open. Why you would use this? Like I said, it's sort of a niche solution, which basically means, I don't know, not everybody would want to use something like this. If you have information that you're very determined to protect, then you're going to want to use mTLS, because the cost of setting it up is going to be worth it to protect that kind of information. So medical information, financial information, this sort of thing. You can also see, like, some companies will do it as software as a service. So if they have a lot of clients that want to use this, they can set up one system, a bunch of scripts that will do all of the certificate renewal automatically. And then you kind of don't have to spend as much money on each individual customer. And then the reason that I was asking about IoT was, if you don't have that many certificates, then it's not such a bad solution, because on your own home network, you can sort of decide, oh, I don't want to make the renewal process go every 6 months or something. Maybe I just leave the certificate there for 10 years. You don't have to worry about someone trying to hack you on that situation, and you can do everything manual if you only have a few certificates. And then this is something that I did like maybe a year or 2 ago. mTLS in a business context, so like where you might see this in the wild. Basically, we had a customer who wanted their customers to be able to log in securely and make secure orders. So not only did you have the mTLS login, but you also were using the certificates from their card that they were using to log in to sign the order and make sure that the order was actually what they wanted to order and somebody else wasn't doing it for them. So the setup that we had for this, we had 3 servers. We had the WAF server in the front, which was the computer to which the client was connecting directly. Behind that, we had an application server, and then behind that, we had a database server. And the user would connect with the mTLS to the WAF server. Once that connection was okay, then we additionally had to get some information from the certificate onto the application server, which is maybe a little bit more complicated because all of the certificate information stays with the client and the first server that it connects to. And then once we had that information on the application side, then we could use it to maybe check the signatures and stuff like that, make sure that they were doing what they were supposed to be doing. A couple of things to notice about this. Getting cert information from the card to the application. With mTLS, one thing that you have to know is that if you move the certificate information from the two computers to where it was assigned, you're breaking the security agreement, because if you can just take the identity that's supposedly belonging to this computer or this user and just move it wherever, then it's no longer doing what it's supposed to be doing, which is identifying this one location, this one server. So we had to pass this information through the WAF server to the next server, the application server. You can see here that I have Apache HTTP server and mod security. Mod security is a tool that helped us do this. So Apache is the one that's checking all of the information about the certificate, if it has the properties you want, if it has the chain that you want. And then after that, it pulls some information out of the certificate and puts it in an HTTP request. You have to be careful and make sure that all of that information is what you think that you're sending, because if you imagine you have a certain number of checks on all of the different certificate properties, and if those checks are not full enough or not detailed enough, then an attacker can still get past that and pass some bad information into your application. So you have to make sure that you're checking all of the stuff that you need to be checking. Mod security helps with that because it allows you to look at all of the HTTP headers and all of the information in the request and say, maybe I want this header to be this length, I want this one to only have text in it, this sort of thing. And it comes with a lot of standardized rules that will help you do these checks if you don't want to write 5,000 rules yourself. And then, let's see what else. Certificate authority, I won't go into too much detail with that. If you're doing this just on your own, you don't really need to mess with it. We had a lot of issues with compatibility because the users had a card reader, which is some hardware. They had a card, which is a certain version. All of that had to be compatible with some middleware and with multiple browsers, which makes it kind of difficult to get the algorithms and stuff right, because maybe some browsers prefer one version of TLS and one particular set of algorithms. Maybe another browser doesn't want to use those at all. So that can be kind of finicky, and you can set a lot of that stuff in the CA as well as in the Apache server. But if you're doing it at home, you can just sort of take it out of the box, use TLS 1.3, and it will work just fine and be secure. And I guess last but not least is, if you want to try this thing at home, if you're interested in any sort of security stuff, or you have some IoT project that you want to try it on, you can try this GitHub repo that I set up. It has an example of TLS. You can just sort of use it out of the box. There's some information about other things that you might want to set up. And it also has a setup in there if you want to have the negotiation between Apache or between Node.js. You can also set up your Node.js application to use this. And a couple of security things that you might want to think about here. One of the settings that is the most dangerous, or the one that's most incorrectly set, maybe you recognize reject unauthorized in Node.js from Stack Overflow or something like that. Everybody's telling you to turn it off. This is basically telling Node.js or telling Apache, if the certificate doesn't match my requirements, do you let the connection proceed, or do you block the connection? And like I said, with all of these settings, it sort of assumes that you meant to do what you want to do. So for instance, you might want to do that and allow the connection and then redirect that failed traffic to another server, show a nice failure page or something like that. But usually, if it's like your own home server or something, you don't want to allow that traffic. There's a couple of different settings like that. For example, verification depth, cert revocation, this kind of stuff. This is talking about like your whole certificate chain. You have your root CA, you have your intermediaries, and then your leaf certificates. And you want to make sure that these layers in the chain match your requirements. So you can set the verification depth, the number of layers that you want to check. And if you set it, for example, to 2 and you have 10 layers, it's only going to check 2, and then it's going to say, OK, I think this person is correct. If you're in a really big organization, you can have like, I don't know, 20 layers, and the longer that you're checking these layers, the longer the connection is waiting to be made. So you might not want to check everything. You might just want to say, okay, after 10, I think this person is probably who they say they are. But if you want to set it to just one, or you leave it at just one, but there's many different layers, then you might have a much easier time for a hacker to make a fake certificate that matches your conditions. Cert revocation, this is basically something that you should think about if you're building an app with this solution. You have to think about what would happen if somebody, for example, loses their card or a certificate gets compromised. How do you take that out of your solution? If you have something at home, probably it's not going to happen, so you don't have to worry about it, and you can also change the file with the certificates in it and just restart the app. If you have an app in production, you can't really do that. And one of the ways that they sometimes in corporate context check this is they have a certificate revocation list, the CRL, which is a URL that is served in the client certificate, and it tells the server where to go look and see if this certificate has been revoked. This is sort of in debate whether this is a good idea to use or not, because you don't really want to ask the client if the client is valid. It's not quite fair, because they might say, oh yes, we're totally okay. It's an open attack surface that somebody could just put whatever in their URL there, and it would not actually be okay. The debate is that this check is done after all of the other checks have completed, so you're like 70–80% sure that this person is who they say they are, but it's still a question if you actually want to use that for this sort of thing. Otherwise, cert revocation, you can usually just delete the certificate from a folder, and then when the application goes and checks in that folder, if it doesn't find the certificate, it fails. Attributes, algorithms, TLS versions, not really necessary at home. Like I said before, you can only use this, or you're only really interested in this if you have like hardware requirements or more complex compatibility requirements. But if you get into that sort of thing, you definitely want to be sort of careful about who is going to be like the ultimate truth in which algorithms you choose. So this is another thing that you can set in Apache server, which set of preferred algorithms are going to be the best ones. And you should set it to the server so that your choices, your more secure choices, are selected first. And then one of the weird things about mTLS is that this connection, the information about the connection, is stored in RAM, at least for Internet Explorer and probably Edge. So you're storing this information on the client computer, and the client computer usually doesn't give you access to that location as the server. So the server can't go and tell the client computer, hey, remove this information from your RAM. We want to close the connection. And in addition, like I said before, it's on the transport layer, which means that if you have something happening in your application, the transport layer isn't really aware of what's going on inside of the application. So it's not going to be easy to just say, oh, I'm ending the connection now. This person clicked logout. Now I need to go back to the transport layer and tell them that the session is ended. So what you want to do is you have to get the user to close the entire browser in order to end the session. I think that's it. I don't know if anybody has any questions about that, or if I missed anything, or if it made sense. Okay. Thanks, guys.
Okay, let's see if have somebody any questions. Give me a second.
This is not working so well, honestly.
Questions and polls. No live questions. Have somebody from the public to get a question? Okay.
You mean like when you think that you've issued a certificate and you no longer want to allow login from that certificate? So you have a couple of things. You have settings inside of Apache that are going to tell you where the root and the intermediary certificates are. You usually put them in a file, like just a text file with the root first going downwards. You don't put the leaf certificates, the user certificates, inside of that file. That's just for the chain. So if your chain changes in some way, then you have to manually change that file and restart the server. If you want to change the leaf certificates, then it's super easy. You just tell Apache, I'm going to store all of my user certificates in this place. And if you want to delete one of them, then that user will no longer be able to log in, because Apache is just going to go through that folder and check and see if it matches any of the certificates that are in that folder. And it's already going to have checked the chain. So it has the chain stored in a separate variable inside of the server configuration. And then it goes to the certificate, it checks all of the attributes of the certificate, if those match your conditions, and then it starts going up the chain that's defined in this additional variable and sees, okay, are these also matching the attributes? So you can just delete it from the folder. The other option was the CRL, the certificate revocation list that I mentioned earlier, which basically you go there and it's a big list of all of the certificates. I believe it has serial numbers in it for each certificate, and if you find a certificate inside of that file, then you shouldn't use it. And that's usually used for like bigger corporations that have tons and tons of certificates and they can't just keep them in a folder on their server. The client sends their own certificate, yes. The revocation, that's what I mentioned before. The revocation list is inside of the certificate. It's like an attribute of the certificate, the client certificate. Yeah. Which that's also kind of like a security issue, possibly, because the client is sending the list of certificates that should not be trusted. So they could tell, oh, no, I'm fine, I'm not on the list, but they actually are on the list. You can delete the certificates from the file, but most of the corporations are using certificate revocation lists. The reason for that is because you usually have two different types of auth into an application. So it's not just mTLS, that's like the first security measure, but you usually have something like OAuth behind. So for example, the application that we programmed, you start with mTLS, that's like the coarse-grained block before you come into the application. Once you get in, you log in with username, password, or something. You can use like an OAuth token that's derived from the certificate. And that means that for every request that you make, you have the OAuth to check if the user is okay now. And then mTLS is checking just at the time of connecting via mTLS if the user is okay at that time. And then the certificate revocation list, that check is done after all of the other security checks. So at that point, you're sure that your chain is good. You're sure that all of the attributes in the certificate are good. So you're pretty certain that this person is okay. It's just a question of if you're 100% certain by the time you get to this check.
Thank you. And one more question. Yeah. Second, I give you microphone for a record.
Thanks. You mentioned a few times like idea of like playing with this at home.
Yes.
So I do have a small home lab just playing around. So and it's taking way too much of my time. So it's kind of a stupid hobby. But so I'm looking for like, have you been sort of doing some hobby projects with this like home network? Do you have some ideas where I could waste more of my time? Or basically, like, what would this like the sort of use case in a home network be?
I will say I'm more of a website person than an IoT person, but you can use this to have two computers connect to each other. So you can have multiple servers talking to each other with certificates. You stick a certificate on each one, and then you have a secure communication. You can also use it just like if you have multiple different devices in your home, and then you have a hub. Each of those devices could connect to the hub with a certificate pair. Or you could have the hub working, like maybe you have an Arduino or something, and then you have on your personal computer a certificate, a client certificate, and you connect to the hub with this certificate.
Okay. Thank you, Katelyn.
Thanks, guys.